or type 1 is grass. This is what we're selecting. And please observe this. This is placed in a separate bracket. The reason this is placed in a separate bracket is this must take higher priority than this. The default idea of programming languages is and takes higher priority than or. So if you don't use brackets here and here, it'll perform this first. That is, the Pokemon should have grass type and health points must be greater than 100. This is the first thing it'll perform. If you don't specify that this OR operation should have a higher priority. So the way to do this is to make sure that in our case, we add the condition df of, let's say, type 1. Okay, I'm sorry for that. Type 1 is equal to fire, or df of, again, type 1 is equal to water. And I'm going to put, my default way is to put every single condition in its own brackets. So we have these conditions in its own brackets. Along with these conditions, we have one more condition that we are looking at. Yeah, the other condition that we are looking at is, along with this, and df of HP should be greater than 100. Now remember, these two conditions should be together. These two conditions should execute together, and the result of this condition should be performed and with this. To make or to provide these two conditions together, let's bracket them up as well. When you run this, you're going to get all the responses where type 1 is fire, or type 1 is water, and HP must be greater than 100. Let's see. Let's put this in bracket for our reference as well. Again, all conditions, it's better to always put all conditions in brackets. And there we go, we have it. Only water and fire Pokemons, and their HP, all of them is greater than 100 as we see. This is one way, or another way is to make it a little simpler. Instead of doing two separate walkthroughs in the entire array, you can write df of type 1, and we have an inbuilt function within pandas called is in. Is an inbuilt function within pandas where you can check if type 1 is within a series of values or not. So the series of values I'm going to provide here is that is a function. So within that, the series of values I'll provide is fire, comma, water. Now I don't have to provide multiple brackets and multiple conditions. It'll just search this. If type 1 is either fire or water or is in this list and its HP is greater than 100, we get that particular Pokemon. And that's basically how we do it. Just a simple, fairly simple operation that we're getting to see here. So this is how you get to perform these sort of operations to begin with, and work around them. Anyway, let's move ahead from here over to the next part of this and continue ahead. In data frame, you have some more inbuilt functions apart from just describe, that is info. And this is quite an important function for us to know in the future. When we start our first problem solving, we'll get to know how important info is when we start to work around it. Info will tell us for each column how many values are not empty. Not null means not empty. Null basically indicates that it would be empty. So we need to figure out and know how much or how many um, keys in this element, or how many values of this particular um, column are empty or not. And that's exactly what we're going to do. In our case, all of them have values except for type 2. Not every Pokemon has a type 2. Only few Pokemons have a type 2 value within them. Most of them just have empty. So based on what we have seen here is nearly half of the Pokemons that we have listed here nearly 414 of them are not null, which means 386 of them are null on the other hand. And another important thing we get to note in this is what is the data type of each one. You can see name, type 1 and type 2 are object. It does not identify them as strings. Instead of strings, it only identifies them as objects for us to know and understand. So please note, whenever it comes down to pandas, it doesn't identify anything as strings. It identifies them as objects instead. Apart from objects, every other data type is identified as it is, just for our reference. So you can see here, um, hash is identified as it is, HP, attack, defense, everything are identified, except for these. These are not integers. These are just objects. It's one thing that we need to know because if you want to perform some operations, you need to know what data type they are of, right? So that will be known purely when we do this, purely when we um, identify it in this way. Moving ahead, let's go on to the next one. Now, let's remember in many cases, you would want to perform operations or perform uh, data manipulation and still retain the original data frame to ensure that if any operation you did went wrong, you still have the previous step of operation to do again. So for that purpose, most of the times what we do is whenever we perform any operation on data frames that we are performing for the first time because we don't know whether it will work or not. And if it doesn't work as expected, I need to run all the steps till now again. To avoid that, as a really good practice, we create a new data frame that is df.copy. Now, remember, don't write df2 equals df. If you write df2 equals df, both will point to the same memory location, and whatever operation you do on top of df or df2 will also be reflected in the other one. Just something you need to know. So, yeah, that's one thing you just need to know. Um, just remember, it's always a better thing to make a copy. And when you make a copy of it, you get to make sure or you get to see both will be from different IDs. So if you print ID of df and if you print ID of df2, sorry, not df, ID, you get to see these will be different. However, if you do it as df2 equals just df, you get to see they'll be of same ID. So please don't do that when you want to edit it. So this is how we work around it. Now, I want to know how many values are null in our data frames. This is what I want to know. I want to know in our entire data frame, how many of these values are empty. So I'm just going to write df2 dot is null. Is null is a function, and you get to see which one is null, which one isn't null. You get to see all of these are false except some in type 2, because we know not every Pokemon has a type 2, just has a type 1 of it. And to get to know how many null values are there, you can just use is null dot sum. Sum is just an aggregation function we put on top of it. So you get to know how many null values are where, and this will help us figure out which column has null values so that we can actually work around it and solve it. That's one thing that we need to know. Moving ahead from that, let's go ahead and try to apply some manipulation functions and try to work around it. Now, here's what I want to do. We know type 2 is null, and I don't want it to be null. So what I rather want to do is have a single column instead of type 1 and type 2 separately. I can just write tf.head. It'll give me type 1 and type 2 as separate columns. Instead, what I want to do here is just make sure that we have a single column that will have type 1, comma, type 2. If there is a type 2 value, it'll paste it. If there is no type 2 value, we'll skip it. So if you want to do something like that, there is a way to do that. There is a method to do that. And that is what we are going to do to begin with. So let's do that. Let's start ahead with that. First thing that we need to note here is if you want to perform these operations, just remember, if you remember the functions that we tried earlier, that is apply, map, and reduce, and all these functions, the same functions are applicable even here within um, pandas. Just like how we had these particular functions in Python earlier, we will have the same kind of functions even in pandas. And that's what we're going to use. So let's take a look at this. I have df2.apply. We have an apply function. And what happens is this particular function will apply a function along an axis of the data frame. And here's what it means. See, data frame has two axes, row wise or column wise. If you want to apply a function to each column at a time, you can use a particular axis to apply column wise function. That is in this particular function. If you, okay, let me try this again. All right, there you go. If you apply axis as 0, that is one way to work around it. And if you apply axis as 1, that is another way to work around it. Axis as 0 means that you're going to apply based on the rows. Axis as 1 means that you're going to apply based on columns. So what do you want to do? Do you want to run functions on a row wise, that is one row at a time, or do you want to apply functions one column at a time? What I want to do here is apply functions. You can perform it either way. You can run it one row at a time or one column at a time, up to you. I'm going to try one of them and you can try the other way around for reference. Let's take a look at that. Let's apply this one column at a time and let's create a new column. So we're going to create a new column that will be called df2 of combined types. We're going to create a new column called combined types and we're going to apply a function for each row or each column. Since we're applying it for each column, I'm going to make axis equals 1. This will apply for each and every column. And here's what I'm going to do. I'm going to call a function called combine underscore types. So let's create that function. Now, you're going to receive each and every row or column here. Take a look at this again. Right. So we're going to apply to each data frame column. And let's see what happens. We're going to take combine types access equals 1. Just for our reference and our understanding, here's what we'll do to begin with. In this function, we'll take each iterable at a time. And when we take each iterable at a time, I'll print that iterable. And after printing that iterable, I'll return that exact iterable. So you get to know what combined types will receive. That's the first thing I want to know. So you can see here, combined type will receive this first time, this second time, and third time, and so on. So when you actually provide access equals 1, it's not columns that you're going ahead with. It says columns, but it's not each column at a time that you receive. It's each row because it will specify every single value of the column. It will specify what is the value for name, what is the value for type, what is the value for type 2, what is the value for HP, and so on. So it's going to provide that. And I'll just write here for better understanding. You can take a look at this. Oh, I'm so sorry. Let me use, yeah. You can take a look at this, it's end. That means this is the first iterable it reads. It reads one row at a time with every column name of it. So what we need to do here is treat this as a row. And when we get this as a row, we need to identify if row of type 2 is not none, or let's start with is none. If type 2 is none, we don't need type 2 at all at that time. We just need type 1. That's all we need. So if type 2 is none or it is empty, we will return row of type 1. Otherwise, we know type 2 can either be empty or non-empty. If it is non-empty, in that case, we're going to return here row of type 1 plus a comma and then a space and then plus row of type 2. This doesn't make perfect sense as to why we are combining two different things to complicate it, but it's only for us to understand the function as of now. So if you can take a look at this, it should, oh yeah, one more thing. Yeah, one other thing. Um, so you can see here, I'll just point this out. Right. So you can see here, null and nan are different. I forgot to point this out earlier. So when we talk about pandas, um, identifying nan or not available or empty is not the same as null. So to get to know if a value is nan or not, we need to use some inbuilt functions that are available within pandas just for our reference. All we need to do here is just use is NA and is not NA. That's it. So you can just use, I'll just run here, dot is NA, or you can use within pandas, which has a function in pandas that is NA, that is empty. So you can just run, specify what is the value you want to provide that either is NA or is not NA. So this is what we need to know, right? So yeah, let's continue back with this. So please remember, the basic idea is that we cannot perform this with just none. We need to perform it in this order. So I'm going to make one small change here. Instead of is none, I'm just going to make pandas dot is na. And is na is a function where you can provide any object at just to check if it is empty or not. It will return a Boolean value if it is empty or not. That's pretty much it. Now, if row of type 2 is empty or not is what we're checking. If it is empty, we return only type 1. Otherwise, we return type 1 comma type 2. Now that we have done this, let's print df2.head. You can see a new column will be created, which is going to have grass, comma poison, and so on. And in fire, comma not anything empty, it's just going to give you fire because we have checked for the condition if it is empty or not. So just a basic thing that we need to know when it comes down to pandas, we cannot search something as none. Instead of that, we have to perform some operation like this instead. Now, this is the next thing. Followed by this, we have one or two final functions in pandas, after which we're going to apply this in a real world problem that we're going to go ahead with. So let's start with that. The final things that we're going to take a look at this here is sorting and aggregation, or saving the file and so on. Just some one or two simple functions. Once we have done this, we can move ahead to the next part of it. So we'll do sorting, we'll do aggregation, that is grouping, and saving the files. These are the three things that we mainly need to know. Once we know this, we can move ahead. So let's start with grouping. We have, similar to what you use in SQL databases, group by available. So you can group by something and then apply aggregation functions like sum, mean, sorry, not median, min, max, count, all these aggregation functions you can apply after performing group by. And here's how it works. If, okay, let's create a question. Which type of Pokemon has the best average defense? This is what I want to know. Simple question. There are so many types of Pokemons. Which one has the best average defense? Now, to know how many types of Pokemons there are, I'm just going to use df of type 1 dot unique. If you run this function unique, it's going to tell you it's going to list all the unique values of that particular column. This is one way we can take a look at, and this is one way we can work around it to begin with. Now, moving ahead from here, moving over to the next part of this. Right, yeah, so we're working on this grouping. Right, so let's continue ahead with grouping. Now, moving along here, the next thing that we need to know here is, given there are so many different kinds of unique Pokemon types that we have, how do I get to know which type has the best average defense? When I say best average defense, I want to calculate the average defense of all grass type Pokemon, the average defense of all fire type Pokemon, and I want to know which Pokemon has the best, or sorry, which type has the best average defense. I don't want to know which type has the highest defense, or which individual Pokemon has the highest defense, or which individual Pokemon has the highest or lowest defense. I want to know which type, when you consider all the Pokemons together, get an average of their defense, which one of them has the best defense? That is what I want to know. So you might come up with some theory of your own, like it could be steel or it could be something like that when you think of it. But yeah, let's see it for ourselves as to which one it actually will be. So for us to do that, let's start with the logic. I need to group each Pokemon by its type 1. I need to take all grass Pokemon and group them together. Then I need to take all fire Pokemon and group them together. Once we have grouped all the grass type Pokemon together and all the fire type Pokemon together, then I need to take average or mean of the defense key. Same goes here as well. I am so sorry. Please hold on for just a minute. Kindly hold on. I'll just be on mute for a few seconds. Hey everyone, again, sorry for the slight delay. Terribly sorry for the slight delay of maybe a minute or two. But let's get back to this very quickly. So back to the point that we were making. We are trying to find out the mean defense of each of these Pokemon, and we want to find out which is the highest of it. So once we find or once we group the Pokemon, particularly to begin with, from or based on their type 1, we will then get the mean value of defense. And once we get the mean value of defense of each type 1, we will sort it based on highest to lowest so that we can get to know which has the highest mean or highest average defense. That is exactly what we want to do. So let's try this out and see how this works. Now, for us to do this, first let's group by. Let's perform the group by function. I'm just going to group by. Group by is a function that is available, type 1. So I will store this as grouped data. Let's run this. Once you run this, if you print type of grouped data, you'll get to see that it is a group by object. Now that we have grouped it, the next step is to, again, I'll print this because we'll have multiple print statements within this specifically. Let's try it out. Now, once we have done this, let's calculate the average health points of these Pokemons. So remember, we have grouped based on type 1. Once we have grouped based on type 1, the next step is to figure out next one is to figure out what is the mean um, defense of each group. To find the mean defense of each group, I'll just have to use mean defense. Again, we'll combine all of this into a single line of code, but to help us understand each step of this, I'm separating them. In reality, this whole thing will be written as a single line of code just for us to understand. Now, let's take a look at this. We're going to take our grouped data, and remember, it is grouped by type 1, which means for each type 1, you can access every other data. Type 1 is grouped. So we have grass and fire and everything. So given type 1 is grouped, you can perform operations on other columns based on this group. I want to perform operation on defense column, and I want to calculate mean of defense column when we have already grouped by type 1. So that's exactly what I'm going to do. We have already grouped based on type 1. Within this, I need to take it's defense with S, not C. So yeah, defense, and I need to take mean of it. So this is what we're doing. We are taking that group data based on type 1. For each grouped type 1, we are taking only the defense value and we're calculating the mean of it. Once we do this, we get mean defense. If you print type of mean defense, it'll be a series data now because mean defense is just a single value. It could be 75.32, 87.29, could be any value. It's just a mean value. This particular value is a series. So let's just print this series, print mean difference. You get to see this is the index and this is the value. Again, index and value. Again, index and value. And as expected, you can see steel Pokemons have the highest defense. But when you have a lot of values like this, it's going to be difficult to know which one has the highest, which one has the lowest. You might have to calculate a lot. In order to avoid calculating so much, just use dot sort underscore values. Sort values is an inbuilt function in pandas again. Just like we have sort in Python, we have sort values in pandas. So the whole idea of sort values is similar to sort in Python. It sorts values either in ascending or descending order. The only difference here in sort values is you're not going to use keys as reverse equals true or false. Instead of using it as reverse equals true or false, we will use it as ascending equals true or false. That's the only difference. Because let's remember this entire package is not written by Python developers. It's other developers. It's third-party developers which we use. Hence, some of the usage of it will be different than default Python. So I want to have this value in descending. So I'm just going to write ascending equals false and run it. There we go. Normal type Pokemon have the worst defense. Steel Pokemons have the best defense, on the other hand. You can run this or you can perform this whole operation in one line as well, and I'll show you how to do it. We are grouping by type 1 first. The moment we have grouped by type 1, immediately we are then calculating in this group data. I need to take defense and I need to find the mean of this defense. After I calculate the mean of this defense, I'll get a series to which I need to then calculate sort values that we are doing here. You can do this entire operation in one single line like this. And this is when the first time you look at